So I would like to introduce the next speaker. His name is Michael Elliot. He is a blockchain engineer at MakerDAO. And yes, welcome. And you would be talking about sort of blockchain state management in the CDP protocol.
Portal, yes.
Portal, sorry. Misread it. Thank you.
Great, thanks. Hi, everyone. I'm Michael Elliot from MakerDAO. And last year, I worked on the development of the CDP portal, which is Maker's official dApp for creating and managing CDPs. So during the development of the CDP portal, there were quite a few challenges that we encountered. And so this talk is about those challenges and some of the solutions that we came up with to solve them. And one of those solutions was Multicall, which is the library for managing state in the CDP portal. So this is the UI here for the portal. And as you can see, there are quite a lot of variables that we need to track. And so if you kind of think about what a dApp is, a front-end dApp, it's really, it represents the current state of certain values in the blockchain. And so we needed a way to do that, and we achieved it by polling. So if we're polling for, say, 20 or so variables, and the way that Web3 works with that is that each request will go out separately. So every 5 or so seconds, if we're polling, that ends up being a lot of different requests. And so that was the first challenge that we encountered, this sort of Web3 request overload. And here is what the network tab looks like in Chrome after a while. And to make matters worse, this is the way the browsers work, before a request goes out, there's a pre-flight request to check if the actual main request has permission to be made. So that doubles the amount of requests now that are going out. And that's just not ideal, and it degrades the performance of the dApp over time. So that's the first challenge. And the second challenge, which is related to the first, because all of these requests are going out separately, independent of each other, and let's say that most users are using MetaMask and therefore Infura, we don't necessarily know which Infura node those requests are going to hit. And not all Infura nodes are in sync. So some Infura nodes might be like 1 block behind and out of date. And so if you can imagine a scenario in the CDP portal, for example, a user's creating a CDP, it shows the animation, we poll for variables, we find that the CDP has been created, we show the congratulations screen, and then one of the other variable requests that goes out hits a node that is 1 block behind from when that CDP hadn't been created yet. And so we get a variable back that messes up the state of our dApp. So we needed a way to solve for that. And so this is what we could visualize that looking like. So you've got MetaMask there, and the different variable requests going out to each different node with its own blockchain state. The last node there is 1 block behind, so it gets a value back that's not up to date with the other values going, with the other variables coming back. So the solution that we came up with was we thought, hey, wouldn't it be cool if we could just make a custom smart contract, which we deploy, that would go out and it would be able to, just from one request to that smart contract, look up all the different variables that it needs and then return it. So there'd be 1 request, 1 response. So if you were to visualize how that looks, it's something like this. So we have our values aggregator contract. So our request would go out to the 1 node, and it would look up all the state from that blockchain state. And we'd have the guarantee that all of those values that are returned are from the same blockchain height. So that solves the first problem. The second issue was solved by returning the block number within the smart contract. So because we're in a smart contract, we have the ability to also return the current block number or the block height. And this worked really well. So now we're able to make 1 request every few seconds and return a large amount of variables. However, so now we know that all of these variables are from the same block and also which block that is. And that's hugely important. So for example, if we were to look at the block number that's returned from each response, if it's the same block number or lower, we can just discard it. We know it's an out-of-date node, and we can immediately request the values again. So this is the source code for the values aggregator contract. And as you can see, there are quite a lot of variables here that we're looking up. The problem with this, though, is that every time we wanted to look up a new variable, we would have to update this smart contract and then redeploy it, which isn't necessarily ideal. And it's also only specific to our DApp. So then we thought, hey, wouldn't it be cool if there was a general purpose solution to this problem? So a way that we could decide on which variables we wanted to look up on the fly when we make the request. We send it into a smart contract that could then go out and look up those variables and return it along with a block number. And so that's exactly what we did. And we call it Multicall. So the source code is it's available there if you want to have a look at the repo. All of our stuff is open source. And so this is the source code for the Multicall smart contract. With a bit of assembly magic, we're basically just taking in an arbitrary number of state lookups, so smart contract addresses, function signatures and arguments, and return results. And then we go through, we leap through those, make the calls to look up the different variables from the functions that are called, aggregate them all together, and return them along with the block number. So this works really, really well. However, we still needed a way to be able to generate the call data that is sent to this smart contract because of the very specific format that it accepts, and a way to decode the result and put it into a format that our front-end app can consume. And so then we created a JavaScript front-end library called multicall.js. So multicall.js, it takes care of the polling and also checks the block number that gets sent back to ensure that it's not from the same block or lower. So it's completely abstracted away from the front-end app that can just focus on looking up the variables. And another cool feature that we added, we thought, wouldn't it be cool if it could also check the state of the value of the variables returned and only let our DApp know about when those values change. So if you think about it, a DApp only really cares about the values when they change, not if they're the same result. And then finally, we can do result transforms, which is a way to basically run like a custom function over the result it gets back. So to convert it to a currency object, for example, or change the precision, maybe convert it to from way to ether. And so this is how we would use Multicall. So first of all, we would configure it. In this example, we'll pass in mainnet and Fura. And then importantly, we would define our calls. So in this example, we are looking up the total supply of wrapped ether. And we're returning the value and assigning it to the unique key here, total supply WETH. And then just after that, we are applying a transform over it to convert it from way to ether and change the precision 18 decimal places across to the left. And then the second one we're looking up here is the balance of the maker balance of a particular address and assigning it also to a unique key. And then we simply call create watcher, passing in the calls and the config. And then we can subscribe to updates. So the first time this runs, all of the variables that we're tracking will come through this event listener. And then on subsequent times, only when the value changes will our DApp be informed of those changes. And we can also subscribe to new block numbers if we want to, because that's being returned from the smart contract as well. And then to kick it off, we simply call watcher.startWatch. And then that's it. Now, our library is watching for state changes on the blockchain, and we can be notified of any state that gets changed. So that's Multicall in a nutshell. And yeah, I encourage any DApp developers wanting to optimize their dApps that may be encountering this problem and wanting to have atomic reads to check out the source code here. Thanks.
Thank you so much, Michael. I should also mention he's one of our own. He flew all the way from Perth. So I just wanted to ask you, Michael, what would be the next thing that you're working on? Could you share that with us, please?
Yeah, so currently, as a lot of you are probably aware, Maker's working hard on multi-collateral DAI. So I'm currently working on the development of the MCD CDP portal, or the CDP portal for multi-collateral DAI. Yeah.
Great.
Great.
Thank you so much.
Thanks, guys.
Thanks.